to start the class, first thing I will make a review. Everyone, could you tell me what I taught last week?
Derivative.
Yes, derivative of the function. Of function fx, and the definition is
The limit.
the limit h tends to 0 is fx plus h minus fx divided by h. But you need to set and provide it exists. Okay. If it not exist, we just call this this limit just the definition of the slope of the tangent line to f at the point x and fx. So now, before I introduce the property of the derivative, I carry out some examples. Like if fx is equal to the x squared, so what is the derivative of x squared? So now by the definition, I show you the derivative. F prime x is equal to limit h go to 0. So we substitute x plus h in the function x squared. So we get x plus h minus, how about fx x squared, right?
Yeah.
So divided by h. So now we need to see, we could simplify it. The first term, right? We expand that. So we get x squared plus 2hx plus h squared minus x squared divided by h. Now, because x squared minus x squared, we can cancel. So the numerator will become to, will you tell me? Apero, will you tell me?
No, I can't tell you.
You can, no, x plus 2h plus x squared minus x. So x squared is cancelled. So
What's the numerator?
So it would be 2hx
yeah, 2xh.
plus h squared
Yeah,
over
that's
h.
right. Divided by h. So now we can cancel h, right? We have there's a common factor. So I cancel it. We can get
2x plus h.
2x plus h. So could you tell me what is the limit for the 2x plus h when h tends to 0? The first term, right, 2x. Because the first term not depend on h, right? When you take the limit, just 2x. The second term, the limit h tends to 0, just 0. So at the end is 2x. So the derivative of x squared is equal to 2x. So now I have the question, if fx is equal to x3, x to the power 3, could you tell me what is the derivative?
3 times x squared.
Yeah, 3 times x squared. That is equal to 3 minus 1, right?
Yeah.
So if fx is equal to x to the power 4, the derivative will be 4x.
4 plus 1.
So it's 4 x to the power 4 minus 1. So in generally, if fx is equal to x to the power n, n is any natural number first. So could you tell me? Akara?
That would be the derivative of x is equal to nx
Yeah, ms.
nx to the power of n minus 1.
Okay, that's right. Good. If how about if n is a real number? This formula is still true. The derivative is still true. Are you agree?
Yeah.
Yes, that's true. About the proof, I will teach you maybe the next 2 lessons. Okay? So just remember now. Just remember, for any n,
So remember.
yeah, the power for any n, and then you can get the derivative is n times x to n plus 1. This we can call is the power rule. Now the next property. Next property is just simple. Before I introduce the next property, I need to make the new notation for derivative. The operator is d dx. This is the same thing. Okay? So now, if we have dx a fx, that's it. It's a constant here.
Okay.
C, okay? So we can just move out the constant, and then get dx fx. That's another property. If fx plus gx, the derivative is equal to d dx fx plus d dx gx. If this is true, you need to the derivative is exists, provide the derivative is exists. Okay, so now I think we need to do another example. So if fx is equal to 5x to the power 4, will you tell me what is the derivative for this function?
20x
It's 5 times 4x to the power 3 plus
3x squared.
x squared. Right? Okay, good. So today the class will be stopped here. Okay.